physics presentation. The purpose of this lab was to visualize the magnetic field of a bar magnet, which was assumed to be acting like a magnetic dipole. I used two principles relating to the magnetic dipole field strength, and those were the on-axis and off-axis field strengths. And I found a relationship between the distance and the magnetic field strength, which was proportional to r to the power of -3, and I was able to visualize the magnetic field around a dipole, which was the bar magnet. Principles I used were the magnetic dipole field on-axis and off-axis. The on-axis equation gives the strength of the magnetic field in Tesla's on the axis of the magnetic dipole moment, and the off-axis one gives the strength anywhere relative to the magnetic dipole. Experiment: the system was the phone, the surroundings were the magnet and Earth's magnetic field, and the initial conditions of the magnetic field strength due to Earth at Atlanta being 49 microteslas. I used the magnetometer app to find Earth's magnetic north-south axis, and I found the location of the magnetometer chip in the phone. I measured the magnetic field strength on the x-axis at various locations with the bar magnet on one end using a meter stick to find the distances. I assumed that the bar magnet acted as a magnetic dipole and that R was much greater than D so that the dipole equation could be used. I found the magnetic dipole moment of the bar magnet using the collected data, finding a relationship between the distance of the bar magnet in the phone and the magnetic field strength. The magnetic field strength was found to be proportional to the inverse of the distance cubed. As part of my observations, I found that when the magnetometer was far away from the magnet, it measured a near zero magnetic field in the x direction, but when it moved closer to the magnet, the measured x component of the magnetic field increased. The field strength was proportional to the inverse of distance cubed, seen in the graph, which relates the natural log of the distance to the natural log of the magnetic field strength in the x-axis. I used the equation seen there that related it to the distance and the nth power, which I found with the slope of the graph. For my off-axis experiment, I had the same systems and surroundings and initial conditions, and I measured the magnetic field strength at various locations at 45-degree angles to the bar magnet using the meter stick. I assumed the bar magnet acted as a magnetic dipole again, and I measured the magnetic field strength though off-axis instead of on-axis. I calculated the effective magnetic field strength of a bar magnet by removing the known value of 49 microteslas for Earth's magnetic field strength in the north-south axis. The system and surroundings stayed the same, and the initial conditions were a magnetic dipole moment of 1.53 joules per Tesla and a distance of observation locations of 22 centimeters. The code visualized the magnetic field around the magnetic dipole, which was represented by the bar magnet used in the experimental section. I used the formula for the magnetic field strength off-axis to calculate the strength at various observation locations around the magnet, and I found the field strength for 2 on-axis locations, 4 off-axis locations, and 1 45-degree angle observation location. You can see the coding that was used to find the magnetic field strength at various observation locations, on the left being the 45-degree angle, and on the right being, you can see a little bit of an on-axis arrow. And you can see in orange the on-axis, blue off-axis, and purple 45-degree magnetic field strengths. For the magnetic field strength on the line 45 degrees from the bar magnet, the model predicted a value that was 61.1% smaller than the experimental data. And possible sources of error were field contributions from unaccounted for sources like electronics that could have influenced the magnetic field strength, and inaccurate measurements from the phone magnetometer and using the meter sticks. If the experiment wasn't oriented to compensate for magnetic north and I had laid out the meter stick at an intermediate angle, the results would have drastically changed, because it would have been hard to separate the effect of Earth's magnetic field from the effect of the bar magnet, and it wouldn't have resulted in a linear graph that I found using the data with the phone oriented correctly. And I wouldn't have been able to find then the nth power that it was proportional to. If I were to stick two identical magnets together and run the experiment again, the magnetic field strength would have about doubled for all measurements, as would the magnetic dipole moment, but nothing else would have changed. Thank you.